To failure in hours of an important piece of electronic equipment has the given density function. Find big F of x. So now this time, this density function is an exponential function. Otherwise, all the process is still the same. So since it's starting at x is bigger than or equal to 0, so it means our first piece of fx. Okay, now this time they have played an interesting game. Usually this x is less than 0 comes on the top. But okay, they have a right to do this. So we know that we have no probability accumulated when x is less than 0. And then when x is greater than or equal to 0, you know that when x is greater than or equal to 0, f of x would be, we'll start at 0 and then we will go up to x and f of x dx. So that is 0 to x. And f of x in this case is 1 over 1100 e to the negative x by 1100 dx. And the 1 over 1100 can be pulled out. So one shortcut, we know that integral for e power x is e power x. And u substitution tells us this shortcut, that the integral of e power ax dx ends up being e power ax over a. So in this case, first we will put the 1 over 1100 out of the integral, and then the integral of e power minus x by 1100 would be e power minus x by 1100 divided by a, and a in this case is negative 1 by 1100. So a is the coefficient of x, which in this case is negative 1 by 1100. So you divide by negative 1 by 1100. This cancels out with this, and the limits were from 0 to x. So this would be so it's a negative quantity because of this negative. So when you put the upper limit for x, you get negative e power negative x over 1100. And then the lower limit would become positive e to the 0. E to the 0 is 1. So this is, I'll write that, or let's just write it like this first. Plus 1, and then I can change the order as well, write the 1 first, minus e to the minus x by 1100. Determine the probability that the component, and thus the DVD player, lasts more than 600 hours before the component needs to be replaced. Lasts more than 600 hours. So probability x is more than 600. So x is greater than 600. And that would be the integral from 600. So basically you have to see where this goes on the number line. So greater than 600 means 600 to infinity. So, okay, that's how you would do if you were doing f of x, the little f of x. But as I mentioned earlier, if you already have the big F calculated, that helps us calculate any other probabilities much more easily, because now you don't have to do the integration again. So basically, or be x greater than 600 would be, so the big F is cumulative, so it goes in the less than or equal to. So first we will change this into 1 minus probability x less than equal to 600 by the complement rule. And now probability x less than equal to 600 is just big F of 600, because x less than equal to 600 is the cumulative probability up to 600, and that's the big F is. So that's just 1 minus F of 600. So that would be 1 minus, so F of 600 would be obtained from here. 1 minus e to the minus 600 by 1100. And that ends up being e to the negative 6 by 11. Because the ones will cancel out. So you get 0.58, 0.5796, 5796 to 4 decimal places. Okay, determine the probability that the component fails before 1100 hours. Okay, let's do that. So before 1100 would be basically probability x less than 1100. So that is just straight up big F of 1100. Because big F is a cumulative up to 1100. And as I mentioned before, in continuous distributions, it doesn't matter whether you include a point or not. So less than 1100. So technically, the big F of 1100 is probability x less than or equal to 1100, but less than or equal to is the same as less than in continuous case. So big F of 1100 would then just be 1 minus, look at here, e to the minus x is now 1100. So 1 minus e to the negative 1. 0.632, 1.